Hi, my name is Peter Thomas, President of Resource Compliance. This short video will look at some of the requirements of IIAR Standard 9, Chapter 7. Before studying Chapter 7, let's consider the big picture. First of all, the title of Standard 9 is Standard for the Minimum System Safety Requirements for Existing Closed-Circuit Ammonia Refrigeration Systems. The 9 in Standard 9 is an indicator that it is IIAR's 9th published ammonia refrigeration standard. Standard 9 contains 8 normative chapters and 6 appendices. In this video, we'll examine the normative content in Chapter 7 and explanatory material in Appendix A. Chapter 7 is by far the longest chapter in Standard 9 and contains the minimum system safety requirements that are applicable to all systems, regardless of when they were built. Chapter 7 has 4 sections which address location of equipment, general system safety requirements, machinery room requirements, and general equipment safety requirements. In this video, we'll explore the requirements of Section 7.4. Standard 9 requires that ASME vessels and heat exchangers be protected from overpressure with an ASME relief device. While Standard 9 does not include prescriptive requirements for sizing relief valves or termination piping, it does mirror Standard 2 in requiring that relief valves terminate to atmosphere at least 15 feet above grade and 20 feet from a window, ventilation intake, or exit door. If the termination point is on the roof, the termination height can be reduced to 7.25 feet if that roof is occupied solely during service and inspection. This same requirement is applicable to platform surfaces, such as condenser platforms. IIAR 9 requires that relief valve piping be configured with provision for draining moisture from the piping. Where a liquid can be trapped and cause overpressure due to thermal hydrostatic expansion, overpressure protection must be provided. The images on this slide illustrate 2 different types of hydrostatic relief devices. Standard 9 requires a hydrostatic relief device when liquid can become trapped in any of the following scenarios. 1. Automatically during normal operation. 2. Automatically during shutdown, including an alarm or power failure. 3. During planned isolation for standby or seasonal conditions. 4. Due to an equipment fault. Or 5. Refrigerant pumps and connected piping must have a means of protection from hydrostatic overpressure. IIAR 9 clarifies that if hydrostatic expansion is only possible during maintenance or service operations, administrative controls are acceptable in lieu of a relief device. Section 7.4.4 requires any vessel connected directly to a compressor suction line to be equipped with a high liquid level control to cause the compressor to shut down if high liquid level is detected in the vessel. Similarly, Section 7.4.5 requires compressors to be configured with a high discharge pressure limiting device, often called a high pressure cutout, to shut down the compressor when the safe range is exceeded. The location of ammonia piping is restricted in Section 7.4.6. Piping must not obstruct a means of egress. Piping must not be placed in a shaft containing a moving object, such as an elevator. Piping must not be in a means of egress that is enclosed and accessible to the public. Piping can be installed underground so long as it is protected from corrosion. And finally, where piping is installed in concrete floors, it must be encased within a pipe duct. Standard 9 requires instrumentation and controls to be provided to indicate the operating parameters of the refrigeration system and equipment. Standard 9 matches Standard 2 in requiring facilities to have a method of monitoring the concentration of ammonia during a power failure. Appendix A suggests that a portable ammonia detector is an acceptable means to adhere to this requirement. Refrigeration system safety settings must be limited to authorized personnel only. This is often achieved through password protection on a PLC HMI. Any instruments and visual level indicators must have a maximum allowable working pressure equal to or greater than the system in which they are installed. Section 7.4 concludes by addressing visual level indicators. First, sight glasses must not be installed where risk of hydraulic shock exists. Second, all level indicators must be protected from physical damage. Third, with the exception of a bullseye column, linear level indicators must be fitted with internal check-type shutoff valves and have protection against accidental breakage of the glass tube from any direction. And finally, when bullseye sight glasses are used, they must be compatible with ammonia and sized for the intended application. I trust you found this training on Section 7.4 of IIAR 9 helpful. I welcome any questions or comments that you might have. Feel free to reach out to me using the contact info on the screen. Thank you.